What's up, guys? It's Monday, May 11th. We're going to do the last section of Chapter 2 today, 2.7, which is talking about one last transformation, which is called a dilation, where the figure is actually going to get either larger or smaller from the original image. All right. So if we read this, it says a dilation is a transformation in which a figure is made larger or smaller with respect to a point called the center of dilation. All right, and they give you a kind of a picture. So first thing we're going to do is just identify a dilation, which we're seeing is it a dilation or not. All right, so this is simple. Problem A here, they're asking, is this a dilation or not? And it's saying if we took lines from a point and connected corresponding vertices, they do meet at a point. So the blue figure is a dilation. In problem B here, these are the exact same size, okay? These are congruent figures, not similar figures. So problem B, this is really just a translation, right? If we slid this figure to this figure or vice versa, we would get the other figure. So it says here the figures have the same size and shape. The red figure slides to form the blue figure. So the blue figure is not a dilation, it is a translation. All right, let's look at an extra one real quick. Tell whether the blue figure is a dilation of the red. So the blue one gets smaller from the red one, but it's the same shape, right? It's a similar figure. So yes, the answer would be yes, this is a dilation. All right. So just kind of knowing that a dilation is an image where the shape is similar, it just gets larger or smaller. Okay. So let's read the next part. In a dilation, the original figure and its image are similar. The ratio of the side lengths of the image to the corresponding side lengths of the original figure is called the scale factor of the dilation. All right, so now we're going to be taking a figure and dilating it, making it larger or smaller. All right, so it says here, to dilate a figure with respect to the origin, multiply the coordinates of each vertex by the scale factor k. All right, so the scale factor, K, is going to tell us how to dilate it, how to dilate the image. So here's your learning target. I can dilate an image by multiplying its vertices, coordinates, by the scale factor. Okay, so it's pretty simple. They're going to tell us what the scale factor is. All right, and we're going to multiply each vertices coordinates by that scale factor to dilate the image. All right, so it says draw the image of triangle ABC after a dilation with a scale factor of 3. Identify the type of dilation. All right, so identifying the type, that's pretty simple. Does it get larger or smaller is what they're asking you. But draw the image of triangle ABC after a dilation with a scale factor of 3. They're saying take each of these vertices, their coordinates, and multiply them by 3. All right, so that's what it's going to show you here. Here are the vertices of the original triangle, ABC. All right, 1, 3, 2, 3, 2, 1. They're saying use a scale factor of 3 and multiply each of these coordinates by 3 to make it larger. Okay, that's what they're showing you here. So it's saying multiply each x and y coordinate by the scale factor of 3. All right. And then here are the new vertices of A prime, B prime, and C prime. All right, so they basically just multiply again these vertices by 3, and we get 3, 9, 6, 9, and 6, 3 as our new vertices, and then we can draw our new triangle here. Okay, and it just says the image is shown at the right. The dilation is an enlargement, okay, because the scale factor is greater than 1. So what it's saying is when the scale factor, which was 3 here, is greater than 1, it's going to make the original figure, it's going to make it larger. So it's going to be an enlargement. Okay, so let's look at what happens when the scale factor is less than 1. All right, so here's another example. Draw the image of rectangle WXYZ after a dilation with a scale factor of 0.5. and identify the type of dilation. All right, so same thing. We're going to take each of these vertices, coordinates, and multiply them by 0.5, or take half of them. All right. So here are the original vertices, okay, of w, x, y, z. They're saying multiply each x and y coordinate by the scale factor of 0.5. So they're taking half of each x and y coordinate, and we end up with our new rectangle's vertices. And here's our new rectangle. All right, we just multiply each of their coordinates by 0.5. We get this, and it says the image shown at the image is shown at the right. The dilation is a reduction because the scale factor is greater than 0 but less than 1. So what this example is showing us, is that when we multiply by something that is less than 1, it's going to make the image smaller. All right, it's going to be a reduction. Okay, so again, to recap, when the scale factor is greater than 1, it's going to make it larger. All right, when the scale factor is less than 1, but greater than 0, it's going to make it smaller. Okay, but that's really it for dilations. You guys are going to go into big ideas now and do this 2.7 practice here. Okay. If you have any questions, please email me or ask in the discussion thread. Otherwise, I will talk to you guys tomorrow.